Okay, ladies and gentlemen, here we have a nice little version of Jenga called Jenga Quake. And as we're playing, we're going to be able to observe it shake the whole tower periodically. That'll be creating what will eventually become an unbalanced force that will act on the whole tower and possibly top it over. But we're demonstrating Newton's laws of motion, just the same in this Jenga as all the other Jengas. And my lovely assistant, my wife, is here to join me. So with this, we have Newton's first law, objects at rest are staying at rest, except for this one right here, which was acted on by the unbalanced force of my fingers and moved. You're also noticing Newton's second law, a force necessary to accelerate the masses. Every once in a while, you'll notice that it shakes. I almost touched it with two hands and broke the rules. Bad, Mr. Skinner. The shake is also acting as Newton's second law of motion. It's accelerating the mass. Even if it's just a tiny little bit, you'll notice it'll vibrate and start to shake as the tower gets taller and taller each round. Okay. Eventually, that unbalanced force will be so strong that it will probably cause the whole thing to tumble down. You're also noticing Newton's third law in action. For every force, there is an equal and opposite force. As the tower starts to shake, you'll notice it always shakes back. So you're seeing these unbalanced forces trying to equalize themselves because of the inertia of the tower. So it's basically resisting the shake unto itself because of its own inertia, which is basically Newton's first law all over again. So we've got all of these factors coming into play as we go. And so your job is going to be to draw the diagram and identify all the forces. Normally, we've got a nice balanced normal force in the bottom of our tower here that's holding everything up, and gravity and the weight of all these pieces. And since the weight isn't actually increasing, the only gravitational change that's occurring in this is the fact that it's getting taller. So that is actually increasing the gravitational potential energy. Okay, and therefore it's increasing the gravitational force as we go. And it's creating the unbalanced as we get taller. Your job will be to draw the tower as it's being built and then showing me all of the forces, both in balanced state as well as unbalanced state. Newton's second law in motion, once the object began to move, it didn't stop until it reached the unbalanced force of the ground that time. Ooh, we're going to get it nice and shaky now. And we're going to start to see that Newton's third law is going to come into action every time we get a shake here, with Newton's second law shaking it. Force is accelerating the mass each time. Wife's getting kind of thoughtful. She actually lost the last round. We'll see if she can handle it this time. I think she's probably going to win because she keeps adjusting her moves like that. Oops. Jeez, I can't find a good piece. Is that going to be a good enough piece? Ooh, Newton's second law moving it. Ooh, just barely. Eventually, we're going to have the unbalanced force due to Newton's first law. It's going to cause the inertia of this whole object to eventually come down, or Newton's second law, the shakes are going to cause it to come tumbling down as well. Okay? It all works out to be basically the same, but your job is to draw the diagrams and identify all of the unbalanced forces at work. That one's not going to move, is it?
Mm-mm.
I don't think so. Found one. Ooh, Mr. Skinner. Back up a little bit so that we can see the unbalanced force, shaky, shaky. Unbalanced force. Make sure that when you draw the diagram of it falling down that you show some sort of an unbalanced force, whether it be the unbalanced force of the shake or the unbalanced force of a finger pushing it sideways. You can see Newton's third law in action every time I push in one direction and it comes backwards. You can see that they're pushing on each other in these cases. Doesn't like it when it shakes while I'm moving the piece.
Shocking.
Oh my goodness, that's scary.
They're pretty stuck.
Getting very exciting here. Tension is rising in the Skinner Jenga household. I don't know if those two are going to move. Don't shake while I'm moving it. Woo! Pro skills. Pro skills. Look at Newton's laws acting. Newton's first law, getting taller, means gravitational force is getting stronger.
Nope.
Boom! And that was Newton's first law in action. Once it started to fall, it didn't stop until the table, the normal force, stopped it.